Welcome back to the Reaper 101 series. I'm your host Adam Steele, and today's video is one about performance. How well your machine can handle whatever it is we're tasking it with. Now, this is a common video between Mac, PC, Windows, Linux, regular computers, weird little things like Steam Decks and Raspberry Pis. They all share a lot of common ground. And hopefully in this video I'll show you a few things that'll help you to get the most out of your machine. Let's get going. Now today's video, like the rest of this series, is brought to you in conjunction with ProMix Academy and the Ultimate Reaper Guide, which is in the link down in the description below. That's the massively expanded version of this course where we walk you through every last little thing from start to finish. There's a kind of a how-to section, then there's the advanced section with all the cool gadgets and gizmos and extras that Reaper can do. Then there's a third section where we talk about recording a band, mixing, mastering, and getting on our way in a more practical application. So check that in the link down below. Now, the first thing to talk about when we're talking about audio performance across platforms on Reaper is the audio interface itself. This is the ID24 from Audient, and I really have used Audient stuff for years and years. And it's one of the many brands that are out there, and at this current time, all the Audient interfaces are USB based. There are other ways of getting audio in and out of your computer. And it really depends what you need in terms of performance, because performance and latency are very much one and the same in a lot of ways. Even though there isn't really any audio processing, so to speak, going on in your audio interface, it's really important to have the communication channel, so to speak, between that interface and your software be as clean and as short as possible. Otherwise, your computer will be waiting for whatever brand your interface is for it to do things like take analog audio from the outside world, convert it into digital, and then transport that across into Reaper. And also going back, it will take some time for that audio to go from Reaper back out to your interface and then be processed accordingly. USB isn't the ideal format for this, but it's also the most ubiquitous. It's everywhere, and so most audio interfaces use it because the chance of you having a computer that doesn't have a USB slot is practically zero. And that means that generally speaking, these kinds of USB audio interfaces are very user-friendly. But there is a middleman, so to speak, in between the interface and the software, and that is what we call the USB host controller. Every computer that has USB has these, and what it does is it takes the USB signals and it interprets them as best it can, as well as anything else that might be plugged into that USB device. So quite often on a USB on a computer, you might have 2 or 4 ports that are all actually connected to the same controller. So there might be a mouse or keyboard, there might be a hard drive, there might be some video capture device, there might be anything you can think of that's USB connected, as well as your audio interface. And so what has to happen is that controller has to kind of store up information in terms of priority for whatever's connected to it. Then it can deliver that information both ways, and that can mean that there's a little bit of an audio delay. Now this is compensated for with what we call audio buffers. So this is where, if I look at my screen and go into the Reaper settings, there is the audio device settings, and there is this block size, which is the buffer. So that's the number of samples that we're giving to the computer to say, here is a little bit of time within which you can work. And if you're starting to run out of audio because we're waiting on, say, the USB host controller, then that's okay as long as you get me more audio before this buffer runs out. And that's what keeps things flowing smoothly. The downside to that is that that adds latency, that is to say that delay that if it gets too big, it can become quite noticeable. These numbers are usually done in powers of 2. So we go, the smallest I've reasonably seen is 32 samples. Then we go to 64, 128, 256, 512, 1024. And by that point, we're really getting into big buffer territory. Once we're getting up to that kind of level, that's really, for me, only reserved for a heavy mix on a computer where there is a really huge amount of information and processing going on, and the computer is really on the brink with a heavy mix of struggling to deliver in time. On a Mac, there is only one system that is used, and that's called Core Audio, and that's absolutely fine. All we have to do in Audio Device is select Audient ID 24. On Windows, there is a different list of different types of communication. There's direct sound, there's wave out, there's a dummy which doesn't actually do anything, which can be useful for testing sometimes, but the one you're really going to want to use is ACO. That was developed by Steinberg, the people that make Cubase, and it's become one of the kind of de facto standards on a Windows PC. And so that works very much like Mac Core Audio. So you select your interface there, and that way that's going to go around the Windows Audio and straight to the interface via USB host controller. If you're in the real kind of pro tier and need ultimate low latency and for the interface to essentially get out of your way, that's where PCI Express and Thunderbolt come in, because they are kind of one and the same thing, at least when it comes to audio. PCI Express, if you open up a big PC, you'll see slot spaces, and those are PCI Express slots where you're going to stick a card in the computer. And what that would do, if it was a dedicated card, like I've used in the studio computer behind me here for years, the RME RADAT card. That card goes straight in, and there is a driver for that, and there is no middleman, there's no USB controller. That's connected essentially straight to the processor in that computer, because on modern computers, that's kind of how they can work. So the PCI Express lane goes straight to the CPU, and because there's no middleman, the round trip, so the latency, can be very low indeed. And with the same buffer numbers, like I'm using a 128 sample buffer on the computer behind me, if I was to use a 128 sample buffer on this computer, this one tells me that I've got a 5.9 millisecond in and a 5.6 millisecond out in terms of latency. With the same buffer size, the one behind me with the RME card is showing 2.9 and 3.6 milliseconds respectively for in and out. So this is half the time, so twice as fast in terms of getting the audio back from in to out with the same buffer size, because there's no middleman, there's no USB. So yeah, if you can find an audio device with Thunderbolt, they're much more expensive, but the trade-off to that is essentially that PCI Express that I talked about, where it's straight to the CPU on a cable. And that means that there is no middleman, so there is much more kind of immediacy. And so it's not just about buffer size numbers, it really is about the whole system. On Linux, there's ALSA and there's Jack. I'm not sure which one of those would be the lower latency option. If you're familiar with Jack and ALSA, then let me know in the comments, because that's something I'm not particularly on the pulse with, but I know that you can choose both of those if your audio interface is class compliant. That means it doesn't need its own dedicated driver, so it's got kind of the means to talk to Linux in its own way. Check that out. Beyond that, the audio performance of the computer, if it's a modern computer, you really shouldn't be having many problems. I have had friends recently who've had old copies of Reaper on old systems, and they've moved the configuration from old computers to new computers, and when you first open Reaper, it kind of looks at the system and goes, what am I running on? What do we have? And how should I work most effectively? And if you then take that configuration from one computer to another, that can cause some issues. So what you might want to do is go into Options, Show Reaper Resource Path in Explorer Finder, and all these .ini files in this folder that's opened, those are the configuration. So if you've imported that from a different system, it might be worth at some point experimenting with deleting all of those, make sure you had a backup, and open Reaper again, and any problems that you're having might just go away when it auto detects the new system you're working on and sets itself up appropriately. Now, audio performance in terms of the real deep tweaks is much more relevant, I think, to older machines, lower end machines, because newer machines tend to automatically work really quite well. A lot of the modern multi-threaded, multi-core processors are really designed to handle themselves very efficiently, and Reaper is very good at taking control of that. This is an M2 MacBook Air. This is a 12-core AMD processor. My home mix machine is a 16-core AMD processor. They all tend to work without much in terms of encouragement, but if you need to really tweak them, let's have a look at some of the performance options. This is in the general Reaper preferences, which is Options and Settings. Now let's start on general and work our way down, because maximum undo memory use can be important if you do a lot of things and need a lot of undo history. You can bump this up from the default 256 megabytes. That way, as you do more and more things, if they're quite complex, let's say something like Melodyne, it can keep more in the memory. One of my favorite things that I change is where it says open projects on startup. I change it from last project to new project. I like that to be super fast when I open Reaper and it just has a blank project. So I'm not waiting around for it to load a project that I might not actually be interested in listening to. Under the audio tab, the general tab, there are quite a few things that you can change here that could be really useful to you. By default, close audio device when stopped and application inactive is engaged. This can be useful. Let's say you were working on a project and then you switch to writing an email. Reaper will essentially be disabled in the background, which is very good for battery life, CPU usage, all that kind of stuff. But if you wanted Reaper to keep going for any reason, like I do with Dolby Atmos production, I want that to keep working even though the playhead isn't playing in the background of the Dolby Audio renderer, I would untick this box, and that's why I had that unticked. There's a tick box here, reduce mixing CPU use of silent tracks during playback. And below that, there's input and output channel name aliasing and remapping. I find this really useful on the studio computer behind me. I tend to have my output channels edited. If I tick that box and click the button next to it for edit names and map, I can move around channels in here, or I can just rename them. What you might want to do is rename them. If you've got a permanent installation in your studio, you might want to go 1 and 2 are monitors, 4 and 5 are something else, 9 and 10 are something, and you can change them from the default names which your audio interface manufacturer has written, which are usually defining the type of input and output that they are, like analog 3, analog 4, which can be useful. I could rename those to equipment that is connected to those inputs, which might make my life easier if it's, like I say, a permanent installation. Let's say ADAT3 was a voiceover mic. I could call that VO mic. And that now, if I bring that up on any of my channels, let's just go out of this. If I was to send a hardware out, one of them would be VO mic, voiceover mic, right there. Which I should have named that as an output. That was supposed to be an input, but the point stands. You can do that with your inputs as well, like I just described. I also, for my outputs on the machine behind me, I have output 35 and 36, which are the last ones, are the ones that were previously driving my monitor outputs. And when we get onto talking about effects monitoring, that wasn't working with effects monitoring. So what I did is I changed channel 1 to be hardware 35, and and 2 to be a hardware 36. And that way, by turning the numbers around, I could have a completely different track order, which can be much more efficient and can enable things that you couldn't do previously. Now, under buffering is where we really start to get into the meat and potatoes of things. The auto-detect number of needed audio processing threads is something that I tend to leave ticked, because it tends to know how many threads I have on a computer and how many it can use. It uses all of them. But let's say you use a computer for something like live streaming at the same time, you might want to untick that and define that it has a few less threads than the maximum, because that way you can have a few threads dedicated to your streaming software and make sure they don't clash. CPU thread behavior, I've left it on automatic, but on some computers I've found that to fine tune it, especially with heavy track counts, I might play with the numbers here and go aggressive or just a little more than aggressive. And that way other threads on the computer tend to get out of the way more. But if you go too high, that can be a diminishing return and actually cause more problems than it solves. So do be careful with that. The media buffer size, if it's playing back, it tends to buffer just over a second of audio. If you've been having issues with slow drives, you might want to bump this up to something like 2400. It takes a little bit more RAM, but in the modern production era, less of a problem. Anticipative effects processing. This is really important for a heavy project, because with this ticked, that means that the whole process in Reaper can start processing effects before the audio that you hear at all. So it's going well before the audio buffer for the interface even comes into question. So it takes a lot of the heavy lifting and does it before anything is going to panic. And there's also allow live multi-effects processing, which in this case is on 8 CPUs. I tend to leave that quite high as well, because modern multi-processor machines are really good at this, and that means you can have an entire bandwidth of live monitoring effects and it will spread them out as needed. Modern processors are really good at this. One that I have unticked is anticipative processing on open MIDI editors, because I found that this toggle switch, if I open something for MIDI editing, like one of these, a MIDI editor, whilst I'm playing audio, sometimes that can cause real nasty grinding sounds. And by toggling this tick box here, that can make that go away at the expense of it taking longer for tracks to be audibly different. If I know I have to delete or move a note, though, I'm not bothered about half a second of latency in the editor, because I've usually already gone past that point or it's coming up. So that's the way that I like to work. Now, there are more really deep dive kind of things that you can do if you're really looking to get the absolute best out of your machine, but I'm going to leave those for the ultimate Reaper guide, which is with ProMix Academy. The link to that is down in the description below. Check it out, because that's where I go into insane detail on everything. No holds barred, every single question answered, everything we could possibly think of has gone in there. But in the meantime, thanks for watching, and stick around for the next episode where we're going to talk about the stock effects in Reaper, the EQs, compressors, all that kind of stuff. But for now, thanks for watching, hit the like button, check out the ProMix Academy course, and I'll see you in the next video.